I've been getting some questions about how to do the three-dimensional molecule, and I will do an example that is not on your assignment, and it's HCN, and this is a molecule. If I draw the best Lewis structure, it has HCN with a triple bond between the carbon and the nitrogen atoms. And an analysis of this, and the whole point of the assignment is that when you have a triple bond, it's made out of one sigma bond and two pi bonds, and that those two pi bonds are in perpendicular planes. And so what I've done here is I've drawn the orbital orbital overlap diagram. That's what I'm doing. The orbital overlap diagram for HCN. So I've got my carbon and my nitrogen, and they are sp hybridized. So there's an sp hybridized bond between the carbon and the nitrogen, and that's a sigma bond. And then there's an sp bond between or hybridized carbon with the 1s orbital of hydrogen, and that's a bond, and that's also a sigma bond. And there's a pair of electrons on the nitrogen, and it's in an sp hybridized orbital as well. No bond, just a pair of electrons. And then we've got the two pi bonds, and one of them is flat in the plane of the page, and then the other one is literally orthogonal, which means in a perpendicular plane. And so when I hold this up, I can see that there's half of the other pi bond, and the other half is below the page. Let's see if we can get that there. So, and to show it to you, so here's my three-dimensional model with half of its pi bond and the other half of its pi bond. And so you can see the ends. And those two pieces above and below the sheet of paper are one of the pi bonds. That's why there's two electrons, because two electrons makes up a bond. And then the other pi bond has two parts, and it is in the plane of the piece of paper. That's the kind of model I'm looking for you to build. It will be a little different if you have a molecule like carbon dioxide, because carbon dioxide has C with two double bonds. Sorry, have to draw the electrons. And this pi bond can be flat in the plane of the piece of paper, but the other pi bond has to be perpendicular to the page. So this one can be just like the green one, and this pi bond has to be sticking above and below the page. Where'd you go? Oh, there we go. Let's see if we can show it over here. Floating up, floating up. Yes, I don't know. Anyway, if you have any questions, let